I'm going to talk about 12 ways to supercharge your Connect add-on. So, why 12? I don't know. It was a nice number, and I didn't come up with it. I'm actually going to talk about the 12-factor app methodology. Who here knows or has heard about the 12-factor app methodology? Great. So you guys, you can just leave and no. You can still stay and ask questions, and I'll be like, oh, damn. So 12-factor app methodology has been created originally by Heroku and is focused on best practices for building applications in the cloud. So software as a service applications. So exactly what a Connect add-on is. So it's focused on how to run maintainable, scalable, secure, and stable cloud services. So that's what I'm going to talk about. And with no further ado, here's number one. That's a really easy one. Codebase. One code-based, tracked and revision control, many deploys. Who here is not tracking his or her code in revision control? Thank you, Taylor. But you don't write code, so. I once was on a project. It was like a really mission-critical project for this company. I'm not going to name any names. Some people might know this company, some people might not. And they had 4 developers. They had no revision control. They didn't like it. They were like, we don't need it. We copy-paste regularly. We have directories called V1, V2, V whatever we want. And we don't look into each other's code. Each of the developers had their own code pages. You can guess how that ended. We had weekends where we had to fix things. We had all kinds of mission-critical stuff going wrong. And we couldn't re-roll because the latest backup was 2 months old. So first thing first, put everything into revision control. Put it into Bitbucket. Because, yeah, we love Bitbucket. And many deploys, that's the next part. You might have one single code base, but you will be deploying this code base or versions of this code base in a lot of different environments. You're going to have your dev environments, maybe a staging environment, integration testing environment. You're going to have production environments. All of those, thank you very much, Tobias. All of those environments, all of the code in those environments must be traced back to your single code base. If you're building a more complex Connect add-on, you might have multiple dependencies, or you might have multiple parts you want to deploy. If they share code, this code should be refactored into a separate library. You shouldn't be copy-pasting code from one code base into another. That's just not done. But I think all of those things are pretty obvious for everybody here in the room. So let's go and take a look at number 2. Dependencies. Who here has been in dependency hell? Yes. Well, we're not going to figure out dependency hell, but explicitly declaring all of your dependencies, isolating them, will help you figure out where hell is coming from. And the special thing with this is, don't expect or don't assume that any dependency is going to be available on the platform you're running on. Don't even assume that curl is going to be available. Make sure it is there. Explicitly define it in your dependency manifest. All major programming languages now have a way to define dependencies. Use it. And also make sure to isolate everything. Work with virtual machines, virtual servers, Docker containers, so that you start from a same exact configuration every single time. Because otherwise, dependencies might slip in. One other thing that's where dependencies and explicitly declaring all of your dependencies helps is figuring out how vulnerable your application might be. Because you will have a full dependency tree. You will see all of the dependencies that your dependencies depend upon. And now you might see like, okay, wait, there's been an attack on this library, or this library has a security issue. I should be following up on this because my Connect add-on depends on this library. Those things happen. We recently had such a problem. You've probably heard about it and got an email about resetting your HipChat password. Next one, config. Don't store your config in code, or in stone for that matter, because then you might say it's the end of the world and nothing happens. A lot of people, myself included, especially in the earlier days, love to embed everything into code. Just static strings. I used to be a Java developer, so it's all static final strings with fixed URLs, sometimes even usernames, passwords, whatever. It's easy, it's fast. We'll change it later. And then you commit it by accident into your source code repository, and then you make it public, and then you have to change all of your passwords, because now everybody knows your password. And that's just one thing. Config is everything around you're connected on that changes from one environment to the other. This is going to be connections to your backend services. This is going to be certain set of files you need. All of these things are configuration, and they should not be in code. Hell, they should not even be in a config file somewhere, because that's not scalable. You can have a dev config file, then an integration config file, a test config file, a prod config file, and then you get multiple developers, and suddenly you have a Maarten config file, and Tobias config file, and a hand config file, and so on and so on. And then you have, well, this was test for release 123 hotfix 347 config file. That's not really scalable and maintainable, and you're going to get, yeah. So what 12-factor, the 12-factor app methodology focuses on is put your config in your environment as environment variables. It's easily scalable. If you need a new environment, set the environment variables for this environment and you're done. It's always in the right environment, and the config is always the right config for this environment. You can't miss. You can't check in environment variables by accident into your source code repository. You can check in a config file by accident, even if you use git ignore. And environment variables are OS and language independent, so they will always work. Whatever language you're using, whatever OS you're using, it's easy, it's fixable. So that's what the 12-factor app methodology tells us. Next one, backing services. You should treat backing services as attached resources, or maybe just as Lego bricks. You should be able to take out one Lego brick, change it with another one, and the entire house should still be exactly the same, but maybe have a blue roof now. What is this explicitly? We like connecting our tools to maybe a local file system if you're in development, and a local version of MySQL. But if you're going to go to the cloud, if you're going to deploy on AWS or Azure or whatever you want, you're probably not going to connect to the local file system. You might connect to an S3 bucket or a CDN or whatever for your files. If you don't configure all this, the simple URL and credentials, you're going to get in trouble. Because then, once again, your config might be in your code, or you might implicitly assume that certain things will be there, like you might actually be deploying on a service that doesn't have a file system. So if you implicitly depend on the file system, you've got a problem. So you treat all of your backend services, all of the services you're going to use, databases, file systems, queues, whatever, as external resources, as attached resources. The only thing you know about them is a URL to reach them and credentials to use them. And everything else, that's config. And this also helps with changing platforms, changing backend services. Simply change one environment variable, and you might have a different backend service behind your app. Number 5, build, release, run. Strictly separate build and run stages. Or separate your garbage and make these bins way too heavy for some reason. Whoever designed these bins, they loved smileys. Anyway, what's a build phase? Everybody here knows a build phase. It's where stuff goes wrong. You press build, and then suddenly things fail, your tests fail, or your code doesn't compile, or something else fails. The build phase is where you try to build your code, where you try to get all of your dependencies together, package into a nice little release, and that's the release you can actually go and start running. And the build phase should be, as complex as needed, should be run by a developer and should be monitored by a developer. The next step is going to be the release. Once you have your build, you have your binaries, you're going to combine these together with your config into a release on a certain environment. That should be pretty easy because all of the hard stuff has been done in the build phase, your developer has checked all of the errors, fixed them all, build is green. You can now combine them with those nice environment variables that are already in your environment, and you're ready to go for the run phase. And the run phase should simply be press the button, it runs. The run phase should be the simplest stage of all, because this is something you want to automate. Because if suddenly a really big company buys your add-on, 10,000 users suddenly pop up and start using your add-on, you want your application to be able to scale really quickly, automatically. You want those processes to be able to simply take the release and start running it on different nodes. Same when you have a small Connect add-on. You're a single developer company. Your add-on, for some reason, breaks in the middle of the night. You want your application to be able to restart automatically. So you want to be able to have a run phase that's really simple, really clear, and that can depend on the fact that it went through a really good build phase. Next one, processes. So these are going to be like a bit more technical, and this really depends on the programming language you're working with. So make as much of your processes in your app stateless, as much as possible. Of course, you can't make everything stateless. I haven't heard of a stateless database yet. We can try. But if most of the processes in your app are stateless, it doesn't matter if one of them fails, because the end users will just go to the next process and they will not know. So what does it mean? For example, if your Connect add-on has a wizard in it, and you need to have a couple of steps of configuration or stuff like that, save after every step. But don't save it locally in your app, save it in a backing service, in a stateful backing service. So that if something happens with the node the customer is currently on, they can switch to a different node and they will still have all the information they were already inputting. It also helps in quickly scaling. New people get on board, new users get there. We just run up a number of new stateless processes to handle all those requests, and they can still connect to the database. So some of the backends will be stateful, but all of your front-end processes should be stateless. And the one thing that's always, if you're building a Connect add-on, the one thing that should always be stateful is going to be your tenant information. So you're always going to have client key, shared secret, those kind of things. Those should be kept in a backing service. For example, if you happen to use Atlassian Connect Express, so if you're writing a Node.js or a JavaScript add-on, then you can simply pull in one of your favorite databases, and that will be the stateful part of your Connect add-on. Everything else should be stateless. Next one. Port binding. Again, now we're getting a bit more technical. Export services via port binding. Basically, this says your app should be reachable through a URL. Nothing else. Or through multiple URLs, because you might have your add-on descriptor available at a certain URL. You might have some callbacks available somewhere else. You might have some REST APIs available somewhere else. But all of those endpoints should be simple URLs. In most programming languages, you get this for free. And this also helps because now your application, your Connect add-on, can be a backing service for another Connect add-on. For example, you can have a free Connect add-on, you can have a paid for Connect add-on. Both might share certain basic functionalities. So you can actually have your free Connect add-on be a backing service for your paid for Connect add-on. Because then you don't have to use the same libraries, rewrite the code, maintain the code. Simply, it's not a backing service. It's another attached resource that you're calling. Next one. Concurrency. So I've been talking about processes, stateless processes. The thing with processes, you can run a lot of them next to each other, especially if they're stateless. And that's a way that the 12-factor app focuses on how to get scalable easily. Is take into account the fact that if you get more web calls, start up more web processes. They're stateless, people can switch between 1 and 2, as long as your backing services are stateful and can handle the load, it shouldn't be a problem. What does it also mean is, for example, again, let's go to a Connect add-on. You might have a number of users using your Connect add-on, getting some graphical stuff back inside of Confluence or Jira, but you might also have admin settings that needs to be configured. Of course, those users, URLs or web pages or whatever are going to be called way more than the admin ones. So you might have multiple processes and even scale out even further, specifically for user calls, and say like these are our user-oriented or end-user-oriented processes, and they just service up certain web pages or whatever. And then you have your admin processes. And you might only have one admin process running at the same time, but have hundreds of user processes, depending on the scale and on how much people are using certain aspects of your application. Same with REST APIs. You can have a single process running REST APIs, or if you know that the load on your REST APIs is going to be really heavy, you can scale out specifically only for REST APIs. Or you can have worker processes. For example, you might be doing complex calculations. You can send those off to a different process and then just hear back again when they finished. All of those things are possible if you start using processes and start using concurrency. For most Connect add-ons, this is probably not necessary, but it's part of the 12-factor app, so I want to share it with you guys and girls. Next one, disposability. So who can tell me what this picture is actually? Who can guess? Chopsticks. Those are disposable chopsticks. I'm trying to get like every single picture should fit at least part of the topic. Sometimes it's difficult. So yes, maximize robustness with fast startup and graceful shutdown. Basically it says your add-on should start up as fast as possible, under a second if possible, that would be awesome. And if it gets killed, it shouldn't be a problem. And killed either gracefully or really like meteor strike, it's done, suddenly killed. Why? Because this, again, let's go back to all of the other ones. This helps with scalability, this helps with, well, if your process is stateless, it's easier to start up and tear down, because you don't have to save anything, you don't have to do try, catch, final, and then do a whole list of cleanup before you're officially shut down. But this mostly helps with scale. If you have a fast startup time, you can scale up really, really quickly. Also for continuous delivery, continuous deployment. If you can test your changes on your dev instance in less than a second, that's awesome. If it takes 10 minutes to build, that's less awesome. If it takes 10 minutes to build and 10 minutes to start up, then you're going out for coffee every single hour, which is nice for you, but is bad for continuous delivery, for testing stuff. And the graceful shutdown is important because who here had the problem that one of the applications, especially on Windows, suddenly gave a certain blue screen? It happens. And the next time we want to start up this application and it fucks. It doesn't work, period. It gives errors, whatever. Those are things you don't want to happen in the cloud, because on your laptop you can just restart and you know everything is going to be cleared. In the cloud, it might be a bit more difficult. Also, if we go back to our build, release, run, if something happens in the middle of the night, you want your application to react fast, quick, and get back online as quickly as possible. If there are certain things your application needs to do when it goes offline before it can go back online, and these things didn't happen, your application won't be back up until you wake up, get all of your clients' calls, and rush to fix it. So make sure your application can be killed easily and starts up really, really quickly. Next one. Any ice hockey fans here? Yes. Can you tell me which league this is? If you know this, you're a really big ice hockey fan. So it's a junior colleague league in Canada, but these are triplets, and I was looking for a picture with triplets. So we want dev, staging, and prod parity. We want to keep them as similar as possible. Guess why? Just guess. Why do you want your environments as simple as possible? Okay. Yes, thank you. You want to keep them as similar as possible because you want to do continuous delivery. You want to act fast. You want to be sure that what works in your machine or in your dev machine will work on production. Who here had a problem, once had a problem like, it works on my machine, here's my code, and then it didn't work on production. I had it. And then I gave them my machine like, here, a new production server, but it doesn't really scale. So the thing with development is that there are certain gaps between writing your code and getting your code into production. And continuous delivery, continuous deployment wants to minimize those gaps. And there are three big gaps. There's a time gap, there's a personal gap, and there's a tools gap. Time gap is, especially in the older methodologies of software development, you as a developer, you write your code, and then 6 months later, it's being released in a really big release, and you have no idea when it's going to be done, and you've moved on. You might even have moved on to another career, another company, you might have won the lottery and retired to Ibiza, I don't know. Then there's a personal gap. You as a developer write the code, but in a lot of times somebody from operations deploys it, monitors it, reports bugs, and then support first has to triage these bugs, then they finally get back to the developer who fixes those bugs, and then waits another 6 months for the release of those bugs, bug fixes. And then we have a tools gap. How many of us are like, oh, we need to use a file system. I use my local file system. Oh, we need to use a database. I'll use MySQL because it's just a simple command, or PostgreSQL, and I have my local database. Oh, I need some queuing system. Well, there we go. I just randomly grab one I like from the internet and use it. And then you go to production, and instead of MySQL, it's Oracle, and instead of like local file system, it's AWS buckets, and you're like, oops. Well, I was assuming you were going to use MySQL, so I made these and these and these changes in my code. Don't do it. That's why you need to keep development, staging, and production as similar as possible. And luckily, there are many ways for us to do this now. We have virtual machines, we have Docker containers. They spin up easily. You can use Chef or Puppet to actually set up all of the tools you need, exactly the same tools as you're going to use on production. You might not have the same RAM or CPU. That's not a problem. You need to have the same tools. So you know that when it works on the development, it is going to work on production. So you can automatically ship it, you can automatically test it, and you can do continuous deployment. Last AtlasCamp, I had a talk about how to go from commit to production in a single click. That's when you need these kind of things. We're almost there. There we go. Next one. Log files. Well, not log files, logs. What's the difference between a log and a log file? Nobody looks at a log file. The thing with log files is we treat them as, we'll look there when somebody reports a problem. But then it might be, I once had a case, somebody called me, yeah, I've been having troubles with your application. Oh, that's nice. When did it start? 3 weeks ago. When 3 weeks ago? I think it was Friday. Okay, let me go and take a look at the log files if I can see anything. Log file was 2 gigabytes. It was like, okay, how the hell should I open 2 gigabytes of text? Notepad++ to the rescue. It worked, yes. And then I started looking. It took me 3 hours to find the first error. And the error was like, that was the first of many. We should have known about this way earlier. Because once we started reaching out to customers, they were like, oh yeah, I had the same problem. I also had the same problem. But I thought you guys were monitoring this. So what does 12-factor app tell us is don't treat logs like something you just put away and look at whenever necessary. Don't write them to a file. Let external systems read them all the time for you. In development, it's you as a developer who's just writing it out or send it out. And while you're doing stuff, you're looking at your log file. You have two screens or you have a split pane, and you're trying stuff out, and you can immediately see the reaction of the log file. That's the way you should use your log file. But in production, you don't want to have a developer just sitting there looking at the production log and saying suddenly, there's an error, we should fix this. No, we have tools for this. We have things like New Relic, Splunk. Use them. Stream out your logs to the standard out of your application and let somebody else, let some other tool monitor them and warn you when some things are going to happen. Those tools can actually tell you, like, this error is about to happen because based on these things in the log files. Last one, admin processes. You should run your admin or management tasks as one-off processes. What the hell does this mean? For me, this was like the hardest one to figure out. And it's actually pretty simple. It's like, if you have a problem with your database, don't directly connect to your database and fix it there. Use your applications code to fix it, because then you're sure it's going to be fixed, and it will be fixed afterwards. Ship your admin processes as part of your application code. Don't write scripts locally on your machine and then run them from your local machine with the credentials of production and just hope everything works. Make them part of your code. Make them part of your code base. Put them in your production environment, and then either contact them through a URL or open a shell directly into your production environment and run them there as a process, next to all of the other processes we've been talking about. And let a developer do this. Don't expect an operations person who hasn't written the code to exactly understand what's needed. Let your developers do this. Let your developers be responsible for maintaining your production environment and for fixing problems in your production environment directly. And also, if you actually put your admin processes into your code base, you can also test them on our instances. You will always be able to retrieve them and to, for example, if you need to regularly do reporting, that's an admin process. Don't keep it on your local machine manually. Put it into the code base as an admin process. It might be a simple Perl script, whatever. But then everybody else can also run the exact same report. And it will always return the exact same information you need. So, everybody still awake? Perfect. Let's go over them one more time, and then you can start asking questions. Or go outside and grab some coffee. I would prefer the coffee, but still, it's not up to me. First one, Codebase. One Codebase, track and revision control, many deploys. For your Connect add-on, put it in Bitbucket. And then deploy wherever you want, using pipelines. Or Bamboo, depending on which version of Bitbucket you're using. Dependencies. Explicitly declare and isolate dependencies. All dependencies. Not just the easy ones like, I need this library to create cool graphical illustrations or whatever, but also, okay, wait, I need this and this and this system library. I need to be absolutely sure that, for example, a Tomcat is installed on my machine. Use those, use dependency manifest, and use tools like Chef or Puppet or whatever you want to use to actually get those dependencies installed before you start running your application. Config. Don't store your config in your code. Don't store it in config files. Store it in environment variables. It's scalable, it's maintainable, and you can't accidentally check in your credentials. Come on, there we go. I have to point it towards there, because otherwise it doesn't work. Backing services. Treat backing services as a attached resource. Treat everything you need as the same way. It's just a URL and some credentials away. Even though it might be local or it might be at the other side of the globe, just treat it exactly the same. You have a URL where you can call it, you have credentials you need to access it, and that's it. Build, release, run. Strictly separate build and run stages. Your build is your stage, is your complex stage. That's where all of these problems should surface. And that's where your developer should be looking at and fixing all of those problems, and you should have a nice green build. And then run is just pressing a button. An automated process should be able to do it. Processes. Make as many of your processes stateless as possible. In Connect, it's impossible to do everything stateless unless you have a static connected on that just serves like kitty pictures. But make as much of your processes stateless so you can easily scale up, scale down. They can be gracefully scaled without any problems. And put everything that requires state, even if it's in the middle of a wizard, put it in a stateful backing service, like Redis or database or whatever. Port binding. Use URLs for your application. That's basically this. Make sure your application is being called through URLs, that you have multiple URLs, depending on what the needs of your customers. Concurrency. Scale your processes. If you know you're going to have lots of REST API calls, make sure there are lots of processes to handle these REST API calls. If you have only irregular admin calls, one process is fine. This especially depends on your programming language. For example, if you program in Java, Java handles all of this internally. It just takes a big blob of resources and then says, I'm going to use threads. Other programming languages actually allow you to define the different processes. And you guys know better than me. Disposability. Make sure that your app can fail. Fail quickly, fail gracefully, and it can start up really, really fast again. This helps with continuous delivery, that helps with scaling problems. It also helps when your node goes down to restart it quick. Keep all of your environments as closely or perfectly similar. This will help in getting to market faster, getting your fixes to the user faster, and making sure that it works on my machine. Problem doesn't surface. Don't treat your logs as an afterthought. Let them help you discover problems before your users discover them. Let them help you fix bugs before they're even reported. Use tools to monitor your logs, and let those tools warn you. All of your admin processes, put them into your code base, treat them as proper citizens of your application, give them the separate process, run them on production, run them against your code base, don't run them directly against the backing services. And let the developer do this, because they've built it, they need to fix it if there's a problem. Thank you, that's it. Any questions?